Good morning, everyone. Thank you for being here on this beautiful early summer day. So my name is Walter Dawydiak. I have the honor of being here at the Center for Clean Water Technology. So some of you may know me. I spent most of my adult life working for the health department, ending as Director of Environmental Quality. It was an honor and a privilege. And somehow I'm blessed yet again. Dr. Gobler made me an offer to come work with the center to help advance some of the science and technology. My mission is basically to make this information as useful as possible to the county and the state, knowing how the state and county entities work and what they need and how. And I'm also on a mission to help accelerate some of the demonstration and implementation projects that you'll hear about today. We have somebody here from the Massachusetts New England Water Environment Association Task Force, and they've been at this a lot longer than we have. A lot of what we've learned were from other jurisdictions, including Massachusetts. And they estimated that it can take 10 years or longer for a technology to go from inception to actual implementation at a cost of about $1.5 million for the vendor, which is an especially difficult burden, especially for small companies. So here in New York, the state and the county and the stakeholders have made a lot of strides in making that more efficient, and we hope to continue to do so with some of the technologies you'll be hearing about today. So I wanted to preface this by saying that many of the slides here belong to Dr. Mao, who you just heard from, the Director of Phosphorus, as well as Dr. Waugh, who is the Director of Wastewater Initiatives, who's been instrumental not only for nitrogen, but other treatment systems going in the ground for demo at the Wastewater Test Center and elsewhere. So I spent most of my career, pretty much all of my career, working on nitrogen, which we understand really, really well, but it took us since the 208 plan in the 1970s to actually come up with an actionable strategy that will finally solve this problem. And a lot of credit to the state and the county for taking the lead and finally doing this. Emerging contaminants, I spent about a decade on, and phosphorus is a subject that unfortunately many of us know the least about because it's by far the least well developed. The conventional wisdom in the 70s and in the 208 plan is that stormwater and other sources were an order of magnitude higher than any septic contribution of phosphorus, and that's probably correct on a regional basis. However, it doesn't account for the fact that nearshore systems in certain soil types are very likely having phosphorus impacts, and you'll be hearing from the DEC about phosphorus guidelines going down to 0.02 part per million. These are lower levels and have even been measured historically by any of the agencies, so the nearshore systems have gotten heightened scrutiny by the state and here in the county. So one of the things we wanted to do was get some of these systems in the ground to really test how they work and what the O&M requirements are and what the impacts are on soil, groundwater, and surface waters. So the county was good enough to give us a $200,000 grant that I helped coordinate on the center's end to come up with the work plan for, but Dr. Mao and Dr. Waugh are really our experts on this. It's being matched by the Center for Clean Water Technology, and the idea is that we're going to install 2 of the systems that Dr. Mao has talked about. So Dr. Mao has tested these in the laboratory. She's validated them on a bench scale. We want to get them in a real world with real variable human wastewater flows over 4 seasons of the year and really see how they work, what the impacts are, and what the requirements are. So one of these, the county has worked with us to put in Lake Ronkonkoma County Park, which already has an IA system but does not have phosphorus removal capability. It's an ideal site because it's in the contributing area to one of the most iconic and impacted fresh surface waters in our county. The other is going to likely be an electrochemical filter at a residential site. We've got a couple of excellent candidates that we're pursuing at that end, and we hope to come up with the final site selection soon. The idea is that this year we're going to start with pre-implementation monitoring to look at what's been going on there, how much of the soil has been saturated with phosphorus, how much of it is breaking through, how far it's going. And after the installation of the IA system, we're going to be looking at the phosphorus going into the IA, out of the IA without the electrochemical module, and out of the IA with either filter or electrochemical removal to see what the efficiency is, and follow that through the soil and groundwater to see what the impacts are to help come up with the assessment, management, and implementation strategy. So I know we're running a little late and we're near lunch, and I'll go quickly. Xinwei has already talked a bit about some of the filters, the polinite and the oyster shell media filters. The nice thing about these is that we could pop them in filter vaults, try them for a couple of years, get a lot of data and experience, and move on and try something else. So that's going to be the case in the Lake Ronkonkoma watershed. This graphic shows you the field installation of that large punching bag looking thing of polinite, which simply gets dropped into a filter vault and sits there until its performance efficiency starts to go down, at which case it needs to either be regenerated or replaced. On the oyster shells will probably be our first effort after the polinite in terms of looking at filter efficiency. As Xinwei pointed out, this has had remarkable efficiency, both in terms of removal of phosphorus as well as post-removal recovery rates. So we're pretty excited about testing both of these. The second technology that Xinwei pointed out is the electrocoagulation. So Stony Brook's been tinkering with different permutations of metals and plate size and configuration to look at novel systems to see if they can be made more efficient and how they can be made more efficient. This particular system shows iron. The phosphate binds with the iron to make a ferric phosphate precipitate that goes down into the sludges and then gets pumped out periodically and removed. The system on the right is a FujiClean CRX. Many of you are familiar with Fuji, which is one of several approved systems in Suffolk County. All of the systems are working pretty well, really well, the ones that are in general use approval. Last data I saw showed that these systems were down to about 12 parts per million. This particular system is especially nice for testing because the upfront part is simply a nitrification, denitrification process of a standard Fuji IA. And it's got a phosphorus filter on the tail end, which is functionally independent and separate with the electrochemical process. So it's good for testing, it's good for looking at the O&M. And if for some reason it winds up not being cost effective, it's segregatable, it'll work as a flow-through IA on its own with no adverse impacts on nitrogen removal technology. So it could be a good first choice. This is the Ronkonkoma watershed. This is one of the nitrogen scorecards. One of the gratifying parts of my career was seeing the sub-watersheds wastewater plan come to fruition. It's really the first, I could talk for hours about the continuum of programs that happened between 2008 and when the county finally took ownership with the state of the problem and tackled this non-point thing, which is vexing at every federal and state jurisdiction. This county has really made remarkable progress in this. This is one of the scorecards, and what you're looking at on the left is a groundwater flow going from north to south. So by far the largest volume component of groundwater entering Lake Ronkonkoma is from that northern wedge, although all nearshore areas there in red can be significant. Lake Ronkonkoma is not particularly remarkable in terms of excess nitrogen loading, in terms of pounds per unit volume of water. Those loadings are high throughout Suffolk County. It is remarkable in that it's just a big pond where the water sits there for a very long time. So the residence time there is extremely long, which compounds the impact of any inputs that go into that lake. So on the right, you see Lake Ronkonkoma County Park, which is squarely in that western portion of the northern contributing area where it's going to have a big impact and any improvement's going to be pretty significant. And we're working with at least one other site within that area and, to come up with the second electrochemical system. As per our WQPRP work plan for the County Water Quality Grant, we're going to list candidate sites, reasons for selection, and reasons for selected technology. This will be reviewed by the Health Department and Economic Development and Planning before a final decision is made. But this is where we're heading right now in our preliminary planning. So this slide shows a county park. And I don't think I've got a laser pointer here, but basically the park is in that upper middle area, and you can see the label for the existing Norweco system, which was an IA system that was installed several years ago. Right now, that effluent goes straight to the leach field, which is a polygon to the south. Those two circles between the Norweco and the polygon is where the vaults are going to go for the filter media chamber. The space is there. It's simply a matter of repiping the effluent. There may be a need for another pump involved depending on the hydraulics and the elevation, but basically we're going straight from the Norweco to the effluent field. We had estimated this entire project for 2 filters at $200,000 for construction, thinking we'd have to build new systems. Because we're making use of a substantial pre-existing system here, we're hoping that the whole budget comes significantly lower than that at the end of the day. And there you see that polynight bag again being dropped into a vault. It's a pretty simple installation. So we're hoping to get health department approval by September and construction by November. The removal goal is going to be significantly more than 90%. We typically see greater than 10 coming in with before the phosphorus filters, going down to less than 1, hopefully significantly less than 1 in post-treatment. We've seen better numbers in the lab. We'd like to see that replicated in the field with the real system. Looking at the O&M, this system may require quarterly O&M rather than biannual or annual, at least in the beginning, to check the plates. One of the concerns is whether the plates wind up plating over essentially with deposits on the plates that reduce their efficiency. They work on very low voltage electricity. It's not a dangerous situation. It's a very simple system. However, if they plate over, then the ions are not available to bond with the phosphates and the efficiency goes down. So that's one of the things we're going to be testing. They're cheap and easy to replace. We just have to figure out how the industry needs to deal with these. How often and with what optimal plate design and configuration. So pre and post implementation monitoring, again, we're looking at soil, groundwater, and surface water. We're going to begin this year, install and get another year of data and report in 2028. So in the next biannual conference, hopefully we'll have positive results to show with recommendations on next steps moving forward. And one of the things the state was particularly interested in, you heard about the upstate work where the soils are very different, more clays and silts than you have in an area with Ronkonkoma, like Ronkonkoma, which is going to have more sands, which are typical in the glacial Long Island deposits. That sand is likely to retain phosphorus less than the organic soils you get upstate. So we're thinking we're going to see more phosphorus breakthrough locally, but we won't know until we actually go in and measure it. And the goal here is to help the state with the statewide resource as well as a county resource. It's essentially going to come up with the workbook for impacts of septics based on different soil types. That'll let us know how much will break through over what period of time. That'll help set priorities as a function of distance of shoreline and geographic area and soil types in the county. And that's the end goal after doing all of these projects. So a quick word, this is Stuart Waugh's baby, and I've been helping along since I've got a lot of experience with environmental health departments. Upstate health departments don't really have a way of assessing effectiveness of phosphorus technology. So the state grant has gone up. It should be available for phosphorus, but there isn't a list anywhere that we're aware of performance, O&M, and recommended system design. So there's no central data source to make permitting decisions upstate. There's 62 counties without a way to share information, and there's no way to ensure uniform sample collection, analytical protocols, and quality assurance, so that these individual health departments really have no reliable way to assess phosphorus removal technology or O&M experience to make decisions on design, approval, and grant programs where they're needed in areas like the Finger Lakes and other freshwaters in Suffolk County. So I had a conversation with DEC, and they were very conceptually supportive of having this in one of our work plan. Before this gets too far away from us, like nitrogen did, and one of the big problems with nitrogen is that there never has been, and there still is not, a central data sharing system. The health department in Suffolk County does accept other data, but it's on a case-by-case basis depending on the source of the data and the nature of the data, and going in a vendor doesn't have certainty or predictability of how their system is going to be treated in multiple jurisdictions. So we want to get off on the right foot here, make sure that we have comparable performance data from uniform and standardized sample collection procedures, all of which need to be ELAP certified. The evaluation of O&M experience is going to be shared to look at best available technologies for funding decisions. That graphic shows that we're dealing both with center technologies and other technologies. That's going to be posted on a website and made available to individual health departments, the public, and all stakeholders. So in terms of a timeline, we're in the process of developing this. We've had some preliminary discussions with some upstate folks in DEC. There's been a great reception so far. We're going to go ahead and refine this in terms of questions like orthophosphate versus total phosphate, how often, how, grab versus 24 hours, set a minimum standard of QA and protocols for operation. We're going to talk to the state about this and the county. We're going to come up with the revised program and a website design and ideally implement this sometime in 2027, hopefully sooner rather than later in 2027. So we think over the years, this is going to be an extremely helpful resource. It's better off getting started now than later. So in terms of take-home messages, phosphorus is definitely adversely impacting our surface waters, just not as well as understood as nitrogen for various reasons, and we need to do better, and we will do better. The center is working with DEC, the health department, and stakeholders, and the monitoring and assessment is ongoing. The planning and management is ongoing. The Ronkonkoma watershed was recommended as a pilot area in the sub-watershed's wastewater plan to focus efforts and do these sorts of demos and analysis to come up with the holistic long-term strategic plan. And on our end, we want to concurrently accelerate the technology development and data sharing. We want to do this because it's going to help the planning and management. And invariably, it's almost a certainty that in some places we're going to need these technologies. And rather than wait 2 or 3 years until we have a plan, then embark on this and wait another few years, we're hoping to jumpstart this and accelerate the process in its entirety so that the tools are available for support now and for use later. So in closing, 72-ish is when the 208 plan started with the Clean Water Act, and 2020 is when we finally figured it out. I mean, a half century was too long for nitrogen. Can't wait that long for phosphorus. I think we're off on the right foot. I appreciate your time. Hope I didn't take too long. Anybody has questions on me or anybody else, raise your hand. You'll get a card. They'll be read or answered in due course. And with that, I'm going to turn over the podium to Ms. Gwendolyn Weinkoop from the DEC to talk about regulatory issues. And thank you all again for being here.